Uh, Hello everyone, good morning. So let's say if you want to scale your production on thousands or 10,000s of Docker daemons, and if you are using container extensively, and if you are dealing with metastore, then I think you should listen to it very keenly. Let me introduce myself. I'm a software developer at IBM, and we offer the IBM Analytics engine service. So we run it, and it is hosted on IBM Cloud, and we provide managed Hadoop and Spark offering, as well as we provide serverless Spark offering. So we create 50,000 plus clusters every year in our managed Hadoop offering, and we recently have achieved a milestone of creating 1 million Spark cluster, serverless Spark cluster. So before I jump into our journey of productionizing the service and what all hurdles we faced along that, so let me explain you how a typical Hadoop and Spark cluster looks like. So you have a management node, you have a data nodes. Normally you set up on a VM or bare metal, and the setup takes forever, and it's very difficult to configure for your use case. So we have a containerized it. So usually this takes a lot of time, and we have containerized, and you get a cluster within minutes. So you just go on IBM Cloud and click and say, okay, I want a cluster, I want to run my jobs, and there you go, you have a cluster. And we provide a dedicated hardware. So today you run your job, and tomorrow again you come back and run job, you will get a same performance. So to containerize it, let me go over a brief introduction that how the Docker works and how the key store is used in Docker networking. So we have a bunch of containers running on multiple hosts. So let's say on host 1 we have a management container, data node, and on host 2 we have another data node and maybe management node of other cluster. So how do you make a multi-host networking work, and how do you isolate both the cluster from each other so they can't see or each other, and they only communicate to their respective nodes? So you bring in a software defined network, and once you bring in a software defined network, you need a metastore which can store network information, and if there are new containers comes up in that particular network, then you need to store that information also. So here go. So we have used etcd for our setup. There are a lot of other options available. Console and Zookeeper are some of them options. We have been using etcd because it's easy to set up, and it gives you a HA capability, and it is quite performant. So this is how you isolate the cluster from each other, and it stores all the information in metastore, and whenever a Docker daemon requires information, it talks to etcd and gets all the information. So now we have our network layer defined, we have our architecture defined, and all those things we coded, we built, and we did our alpha release in time frame of 2016 or something, and we deployed and we made it available for our internal customers, and we had tested it on 100 plus Docker daemons. And by the time we deployed in our beta, we had all the ops and page alerts and all those things integrated. So we were pretty happy. We were getting enough load, and everything was working fine, and our beta release was going well. And suddenly in the middle of night, I get paged that something is gone wrong, and 4 of us got together for our colleague, and we tried to debug that what is the issue and what we are facing actually currently. So we dig up a little bit, and we found out that our service is not scaling up and we are seeing a performance degradation. So the cluster which was coming up within minutes was taking a lot of time, and it's not able to scale also once we went beyond 1000 plus Docker daemons. So we had thought that okay, let's compare it with alpha release, that what went wrong or what we changed in the beta release, and we realized that we were running with a single node of etcd cluster. Instead of that, now we are running with a etcd cluster, and we have enabled SSL on our etcd cluster, and now we are running with 250 plus Docker daemons, and we are seeing a lot of traffic, and we are seeing a lot of cluster creations. So we observed that one of our etcd node was overburdened, and it was taking a lot of CPU, and so now we noticed that why it is happening, and actually we before we move to etcd cluster, we tried some testing, and we had brought down the etcd leader. So if you are aware of etcd, then it in the cluster mode you have a leader, you have a few workers, and you pointed to etcd leader, and so we had brought down the etcd leader and tested. Things were working fine, but when we started bringing up a new Docker daemons, we noticed that something is wrong, and it is not pointed correctly. So we had referenced Docker documentation. Usually it is very good, and we could not find any reference that how do you point it to all the 3 nodes. We noticed that we had brought down the leader, but Docker itself maintains some cache. It talks to metastore, and it fetches all the information and keeps a cache for some time, and then whenever there is a change, it refreshes its cache. So we figured out this syntax, that okay, this is how you point to all of the etcd nodes, and it was quite performant, but did it solve our problem? No, it did not solve our problem, because still there are other causes which are creating a performance issue. So now we are running with 250 Docker daemons. We also observed that Docker operations were slow when we start Docker or stop Docker, or when we create a new network, or when we spawn up a new container. It was taking a lot of time. So we found out that these are the causes, and we tried to find that which component is getting bottlenecked, and why it is happening, why listing and all those things are pretty slow. So actually the container which should come up in seconds, now it is taking minutes. So we found out that Docker uses libkv library to interact with key value store, and that was getting bottleneck. So we were the early adopters of Docker, and at that time the Docker version which we were using was not that quite performant. We started experimenting with a newer version of Docker, and we found out that and we ran a lot of tests, like we created thousands of network and thousands of Docker containers to simulate the same type of issue, and we found out that the newer version is quite performant, and we found the bottleneck in our system, and we replaced with a new Docker version. We tested everything. We had already CI/CD pipeline at that time, and we deployed pretty fast in our beta. So once we found out this issue, we thought, okay, now our problem is solved. We have figured out that why things are slow, why it is not performant, but not exactly, because when you are talking on a scale, you need quite performant hardware. So what etcd does, so etcd stores all the metadata. If you are running in a HA mode, in that case it does a lot of snapshotting of metadata. Every etcd node has to maintain a column with each other, and they have to replicate the data, because if any point of time one of the node goes down, the other two are already available. Those nodes kicks in and handles your environment. So when it writes it to a disk, it needs a higher IOPS, because it has to do a lot of snapshotting. It has to write on a disk, and there are a lot of Docker daemons which are talking to etcd. So we found out that we are running with 8 CPU and 16 GB core machines, and we are using SanDisk. That will not cut it. So let's bump up the hardware, and let's use the SSD, which gives you a higher IOPS. So the etcd writes will be pretty fast because of a higher IOPS disk. And we had run a performance test, and we found out that okay, we need a 16 CPU and 32 GB a machine which can take our load. So we had changed with that. So everything was going smooth, and suddenly again we were getting paged, and there was some issue, and we found out that one of the hardware is not working fine. So every time one of the etc node was going down every time. So today I bring up, and tomorrow again it is going down. So actually at some of the time the system was so fragile that we had our ops team already deployed, but we didn't wanted to take them care of this alert, because we wanted to dig up that why it is happening. We were thinking that there is something wrong with the Docker or etcd configuration, and we had assumed that okay, you get a machine from an infrastructure provider and you see all the machine as a same, everything is the same. But that assumption was wrong, because there was a fault with the machine itself, and we had to change that particular machine. So the lesson we learned is, do not assume anything, and you should always look for the outliers and figure out that what is the issue. Now we again evaluated, we have bumped up the hardware, we have figured out the Docker bottleneck. So we thought now it should have been resolved. So it was resolved, but the thought occurred that, let's say today we are running with 250 plus Docker daemons, tomorrow we'll be running with thousands of Docker daemons. So we started doing performance tests. Once we hit 400 plus Docker daemons, we were seeing that there was a lot of chatter happening between Docker daemons, and it was making a lot of calls with etcd, and we tried to dig up that why it is happening, and we started looking into it. So what we observed is, whenever there is a new Docker daemon registered with etcd, basically whenever there is a new Docker daemon comes into environment, so we have, let's say 400 Docker daemons running, and let's say one Docker daemon has started and it has registered with etcd, it will make a call to etcd that okay, I am there and if you have any containers to schedule, or if I want to make a network with some of the other Docker daemons, then let me know. And the other Docker daemons are also listening, watching for this event, that if there is a new Docker daemon comes into picture, let us know that if it has come up or not, and we can form a network with that or not, or we can schedule a container on that or not. So one call will scatter to all the Docker daemons. So imagine this happen in highly scalable environment where we are creating let's say hundreds of clusters per day. So if you take an average that if it's a 5-node cluster, then you have a 500 daemons coming and going in a single day. So it's a lot of calls happening in between. This was almost like a factorial effect. And we saw that this is one of the cause that why there are a lot of calls happening. The other scenario is like every Docker daemon sends its heartbeat to etcd that it is alive and it is still alive, and it can form a network with other Docker daemons, and it can schedule a Docker containers. So it will make a call that scatters to other Docker daemons, and because they are watching for these events that okay, there are any Docker daemons which I can form a network with. So any even when you create a Docker network, that is also one more call. So anything changes in your metadata, Docker watches for all those metadata, that if you are creating a new network, or if you are creating a new endpoint, or if you are creating a new container, it watches for all those events and it pulls from a etcd that okay, give me all those events, let me refresh my cache, and okay, there is something change in the environment and it gets scattered. So there was a lot of chatter happening and when you install Docker and set up a Docker, by default the configuration of heartbeat is like every 20 seconds it sends a heartbeat. So you imagine that 400 Docker daemons sending heartbeat every 20 seconds, and everybody is watching for everybody's heartbeat, and it is a very it is a lot of network bandwidth. It will use lot of network bandwidth, as well as there is a lot of chatter happening between those things. So we found the at least fix for the setting up a heartbeat, and we change it to 1000 that okay, Docker daemon should send its heartbeat after every 1000 seconds. By that time it should rely on its cache, and it should use that particular thing. But this did not give us a confidence that if we are going beyond 1000 plus or 10,000 plus, it did not give us a confidence that okay, we can scale, our service can scale. At one point of time we thought that are we going on a wrong track, that are we trying to make a Docker and metastore scalable, and instead of making our service scalable. So we wanted to focus on our service to scale. We had tried all the settings, we had turned all the knobs, but it did not help. So we thought, let's look at it differently. Instead of having a shared etcd across all the Hadoop cluster, let's have a dedicated etcd for each Hadoop cluster. So if you are creating, let's say 5 node of Hadoop cluster, then only 5 node will talk to etcd. That way you can avoid the chatters between Docker daemons, and even you can reduce the blast radius, because if you have a shared etcd across all the Docker all the Hadoop clusters, that means if something goes wrong, and if etcd is down or something has caused a network issue or something, then your blast radius is like almost the whole zone if you are deployed in multiple zone, or if you are not deployed in multiple zone, then it's downtime for you. We re-evaluated option, and we came up with a different option, that okay, let's have a dedicated etcd. So only Docker daemons which are part of the Hadoop cluster will talk to that particular etcd. We have a unique feature in our service that it can heal itself. So let's say if tomorrow one of the data node has down, or machine has gone down, or Docker has gone down, anything which goes down, they can heal themselves. And we were pretty sure that, and we had added the same thing for our etcd setup for that particular Hadoop cluster. Because if you when you create a cluster, only at that time you need an etcd, because at that time you are forming a network, and at that time you are registering all the containers. Unless you are creating or adding a new node, at that time you need an etcd. By that time, if things are not okay with etcd, you have at least some breathing period that you can brought up the etcd. If self healing has not kicked up, then you can take care of that. And this actually is a scalable model for us, and now we are running with a lot of clusters. We are having a lot of loads, but still we are not seeing the scalability and performance issue. So the key lessons we learned with all the with this journey is that you should not assume anything, that okay, things will work this way, or the hardware is good and all those things. You have to actually evaluate the options. If you are hitting any issues, you should understand your system thoroughly. We were quite new to Docker when we started using it, so we did not know that how the cache works and how the lib kv library work, but we still figured out. We dig deep and we find out that okay, what all things are wrong, and we could figure out. You should always find if there is a bottleneck in your system. In our case, shared etcd cluster was a bottleneck, and we got rid of that and brought in a dedicated etcd. And you should always make the blast radius small. So let's say if you are using something which is shared across multiple cluster or multiple nodes, then you should always look back and find out that if something goes wrong with that particular component, how much it can affect to my system. Is it going to be go down, or still I can survive or not? So the minimum your blast radius you can survive. So in our case, in case of dedicated setup, if particular etcd has gone down or some node has gone down, then it is affecting only that particular Hadoop cluster, but it is not affecting the other. Service is still running and the other users are not affected. So you should always reduce the blast radius. So these are a few references which I use for the presentation. I'm open for questions if you have any questions.